Okay, hi everyone. This is Monica Sibolite, Senior Solutions Architect at GeoSLAM. We've got a panelist joined already as well. It's Lee Hamilton, Product Manager at GeoSLAM. I think we'll start the webinar now. So buckle up, and I hope it's going to be clear and fun. We will be covering today BIM workflows with GeoSLAM solutions and GeoSLAM data. And we will be talking about GeoSLAM devices and how they fit into BIM workflows, and we will overview that a little bit. We will talk about BIM levels of detail and where GeoSLAM data falls into that. And then we will cover a couple of workflows in third-party packages. First of all, we'll look into Revit with PointCap plugin and without. Later, we'll look at the data workflow in MicroStation as a review again. I will note a little bit about Bentley Systems package, which is called ContextCapture, which allows to take in different types of data. And we'll have a look into PointFuse as well and how to generate BIM information with that. Hopefully, we'll have a good Q&A session afterwards as well. All right, so to start off, in order to get BIM data out from GeoSLAM solutions, the data needs to be captured with our devices, and the data is run through Hub software. In there, you can export point cloud formats as LAS, LAZ, E57s, PLYs, and in GeoSLAM Draw, there are things like DXFs, DWGs, and RCP can be exported as well. This data then can be taken into a variety of different types of third-party packages in order to extract BIM information. So, to start off, it's probably good to have a little chat about BIM levels of detail. Where do we see GeoSLAM data sitting in regards to that? So it's all to 100 to 300 levels of detail, from conceptual design, approximate geometry, and precise geometry. That is what we can see from GeoSLAM point clouds, and that's what is allowed to be modeled, really. So I hope that makes sense. As well, I believe it's a good representation of accuracy, the table defined by Royal Institute of Chartered Surveyors. So in here, they define what accuracy scanners can be used for what type of things. So what we see ourselves fitting in quite well, because our accuracy ranges from 10 millimeters to 20 millimeters, really. It's possible to create and depict such things with GeoSLAM solutions as structural elements of a build, non-loading bearing elements such as partitions, risers, and stairwells, architectural features, facades and cladding, floor plans, and contextualization. In this case, contextualization stands for being able to capture high-resolution imagery with 360 panel cameras, which is a part of GeoSLAM accessories. So usually people would use it for measured building surveys, topographic surveys, and so on. I hope that gives a clear indication of what GeoSLAM solutions can be used for. All right, so for a quick recap and overview, we'll look into Autodesk Revit, MicroStation, ContextCapture, and PointFuse. All right, so firstly, we'll start with Revit together with PointCap for Revit plugin. So if you're using this plugin, you get an installer, which is an executable, and it comes with Revit templates, which you can use in Revit in order to be able to fulfill this workflow. Once the PointCap for Revit plugin is installed, it will appear in your Revit ribbon as PC4R, and it needs to be activated. Once that is done, do not close the Revit and open the draw in Hub. And once the draw is open, there is this little button which is called ForCAD. So this is to call out the PointCap plugin, and that both systems would be able to talk to each other. Once that is hit, you can create a new project in Revit and direct the template to the template which is provided with this plugin. Once that's done, you can start creating levels in Revit with the plugin. So hit on create a new level and create a couple of levels which you would like to use for the modeling. So in here I have level 0 and ceiling. So you can add those by adding plus sign in here. Once you have selected the level you want to create, select the 3D points tool in Draw and click on the particular level you are defining. So in this case, it's floor. And you will hear a clear ping if your sound in computer is on. It will mean that the level has been created. So in this case, I created level 0 and level 1 by pinging 3D points in Draw. Then, in order to create walls, create a section in Draw and click a button Create Walls in Revit plugin. This will open this particular window, which is a pop-out window, which allows you to change offset and which levels you are using to create this wall and other parameters. Then you're in the same way, you select the 3D points tool, and once you start clicking in the draw, the walls start building up in the Revit. In this case, I created this room, and then I ended up creating all of the other walls. There is other tools in the Revit, like for example, create corners or modify corners. So in case you were inaccurate in your draw clicking, you can always fix it up in there. In the same way, you can create windows, for example, and add them by using the 3D points tool. And again, the pop-out window will show you where exactly to click. And in here, you can as well choose which types of windows you want to put in your model. In here, I have already created a quick overview of what is the sequence of the tools to use. And here we are selecting the template from PointCap. We are creating the model. As well, if you have a newer version of Revit, all it will do once you open the older template, it will update it to the newest version. Then you can open Draw, use ForCAD plugin, open PointCap for Revit in Revit, activate the tool, create levels. In here, add the levels you want. So in this case, it will be floor and ceiling. Select the floor, select the 3D points tool, and click on the floor. Here, that's where you hear the actual ping in the sound, so keep your volume up. Then you can create a section. And use Create Walls button in order to start creating the walls. Again, same tool. And always the walls and all the other things you are creating is defined by 2 points usually. And you can see the walls start appearing here. So once this is done, you can use as well the 3D view in Revit, where you can quality check your lines and walls and other things you have created. So in PointCap for Revit plugin, there are a couple of things you can do. Let me just quickly move this. Oh, all right. Here. Just a second, please. Yeah. So you can create walls, windows, 3D lines, and other objects in PointCap for Revit plugin. This is one of the examples, one of our clients, that it took them a couple of hours to create this model by using this particular workflow. Okay, so now we had a request from a couple of users to have a look at how we can use point cloud data from GeoSLAM straight away into Revit. So there are a couple of different workflows which can be used. This one is of a particular example of one of our partners who is very experienced in Revit. And what they would do is they would take the data from Hub, would export the DWG's floor sections and elevations from Draw, would export an LAS file from Hub. They would then put that LAS file into Autodesk Recap and generate an RCP format of the point cloud. In this stage, it's important to mention as well that Draw itself can export an RCP point cloud. So in case you are not using Autodesk Recap, you can do it directly from Draw. Then the data goes into the Revit, and all the sections and elevations and floor plans are created by using DWGs from Draw. And the lines can be as well picked up from those same DWGs or from the point cloud itself. So in this example, what you can see is that you can import the point cloud model directly into Revit if you export it from Draw or from Recap. And here it's a quick overview of the tools which can be used in Revit in order to go straight away directly from Draw to Revit. So in here, what I'm doing is exporting all of the point cloud in the RCP format by just selecting the area of interest, selecting the format of RCP, and selecting the directory where I will be saving it and running the export. Once this is done, I open the Revit platform, create a new project, import that exported point cloud from Draw. It will appear here. You can expand the window and the size views. And as well, you can modify and edit levels in Revit to correspond to correct places in here. So there are as well, depending on what template you have selected, you can choose the north, south, and west views. And then automatically Revit creates two levels, 0 and 1, which you can edit and put where you like. In this case, I'm creating a couple of levels and defining them as floors. Okay. In the Structure tab, you can create, sorry. Okay, in the Structure tab, you can create a new level. So the level button sits just over here. And these are created accordingly. So in my example, I've got 0 level floor, first level floor, floor plan, and the ceiling. This will allow to create me walls later on. So here, that's how my levels look like. So they are basically sections of the data. As well, if you're not sure where exactly the levels are, but you do know the coordinates, you can add the elevations in here. So that's how they look like. What I will firstly do is we'll create a floor, or a CAD floor really. So I can choose a floor button, which is just here. So you have different types of floors as well. And you can start following the point cloud lines in order to do that. This is just a quick example to show you how to get started with Revit platform for this type of work. Hence, it's not an accurate representation, it's more an overview of the tools. So here I'm just creating a couple of walls to show you how the tool looks like. It gives you an angles as well and suggestions where to put the lines, which is quite useful. Okay, so once this is done, and you double click at the end of the line, you have created the floor. So in this case, again, not an accurate representation, but that's how the floor is created along with the point cloud. And that's the floor plan. So now we are ready to start creating walls. The walls and all other tool sets in Architecture tab in Revit, as well as doors, windows, other components, roofs, and so on. So in this case, I'm choosing a particular type of walls. Oh, sorry. Okay. So in here, once you select to create a wall, you have a particular level of different parameters you can choose, like chain, offset, location line, and level. So what I have done here, I defined that my level of height for my walls will be floor level 1 ceiling. This is where I created my last floor plan. Okay, so now I'm just clicking, following the line and creating the wall. Again, there are lots of different parameters on the left corner where you can choose the thickness and different types of walls. And these are the walls which I have created for this example. Okay, so now if I would like to create a windows, I either can create sections or choose where my window will be. So as I'm adding the window, there are edit type options in here, which I can change in order to modify this window. So in this case, I will select different height and width to correspond to correct data. Okay, this needs to be swapped. And then I can as well move my window to correct location. So this is just a very, very quick overview of how to use Revit tools in order to model from GeoSLAM data. I hope that makes sense. All right. So by following the previous workflow from the user as defined before, this is an example they did in Boston. So the scan with Horizon took about 14 minutes. And about 116 million of points have been captured. It then took about 2 additional weeks of scanning interiors and creating Revit model to produce this result. Now we will look a little bit into how to start using GeoSLAM data in MicroStation and what the tools are. So first of all, if you're using MicroStation, there is a touch ribbon in MicroStation in order to import the point cloud. Now, once you do that, if you do not have POD format, that's completely fine. MicroStation will reformat that automatically to their own native format. Then you can clip a volume to create a section in order to start modeling. Then it's important to change the ribbon tab to drawing and select Place Smart Line. And once the lines have been created and they look something like this, you can use Solid by Extrusion tool in order to start extruding the walls. So this is just a very quick overview video of how this is done. The point cloud is being attached. In here as well, there are lots of visualization tools which are quite useful to use. So in presentation, you can select to use intensity values and as well change the different illustration modes from dark to bright, wireframe, and so on. So depending on what you like to use, you can play with that. Once you are ready, you can clip the volume. Again, this is one of the fastest and simplest ways to do this type of work. You can preset sections and floor plans to be cut every couple of meters or centimeters if you wish, and then model from that. This is just the simplest method of doing this. So you can select top view and start creating lines. So again, in this case, it's important to change the ribbon to drawing, or sorry, yes, to drawing, and place the smart line, which will then follow the point cloud in a similar way. And once this is done, Solid by Extrusion tool, which is here in Modeling tab, can be used to start creating 3D and putting heights in. Okay, so that's the quick overview of point clouds of GeoSLAM and MicroStation. And that's a user example which has been done in Denmark. They were building this building and they had to calculate all the living space. Hence, they created the BIM model as well using MicroStation. So here is the point cloud. And this is the BIM model created in MicroStation. Okay, now we'll look a little bit into ContextCapture. We could put a completely other webinar on this because this is quite a large topic. Hence, we'll just overview what can be done, how it can be done, and what it can be used for really. So in order to generate 3D reality meshes with ContextCapture, or textured meshes if you like, point cloud, its trajectory, video and video trajectory is exported from GeoSLAM Hub. That all data is then imported into ContextCapture, and reality meshes, like this example on the bottom right corner, can be created. These can then be taken in lots of different tools in order to start assessing the environment. Hence, it's not exactly per se a CAD application, but it does allow to do lots of similar things. Like in this example, we have worked with Cambridge Center for Smart Infrastructure and Construction and Bentley Systems. In this case, we have captured the data with a couple of different types of sensors. So there was a drone camera capture, there was a horizon data capture, there was TopCon GLS 2000 scanner capture, and GeoSLAM Revo capture for indoors. So this is the final model of combining all of the data sets. And the indoor bit is done with GeoSLAM ZEB Revo. In order to generate indoor models like these, it's important to use a laser like GeoSLAM Revo to be able to create geometries. In here as well, what they did, they used this as a digital twin and added in added the data in their collaborative software of Bentley, which allows to start classifying this data and adding operation information. So it is possible to combine lots of different types of data in order to generate some sort of a digital twin, if you like. Okay, so now here we will be reviewing final workflow, which is GeoSLAM data goes to PointFuse, which is quite an interesting tool. It's pretty simple to use and it's relatively quick. So first of all, once the point cloud is imported, what one needs to do is just hit a button, create mesh model. This will take about 5 minutes and it will generate the mesh from the point cloud. Once that is done, you can hit a button called create BIM mesh model. What this will do is will classify the data such as walls, windows, and floors into IFC format, really, which then can be used further down the line. As you can see from this example, not everything has been picked up, but it did quite a good job. There are simple to use tools to append the classification and change it and add new things. All you need to do is control-click on the area you want to append on particular classification. So you would click on, say, Windows in here, and then control click on this area in here, and you can add it to your classification. So this is a quick export of the data, and this is how it looks like, what it generated automatically. And this is a quick overview of the data. So that's the point cloud and PointFuse. This is the mesh in PointFuse. This is classified results. And these are the CAD lines, which can then as well be exported to IFC and other BIM formats to use in Revit or any other packages. All right, so this pretty much concludes my overview of different workflows. Okay, please do not hesitate to email me with any questions you have. My email address is monica.zbolita@geoslam.com. You're welcome to get in touch, and your feedback on this session would be highly appreciated. Lee, would you like to make any closing statement or notes?
Yeah, absolutely. I think it's difficult to get across the full capabilities in 1 hour. What Monica and I do is kind of encourage anyone who sees the benefit in using GeoSLAM mobile laser scanning technology within their projects or organization, please get in contact with Monica, and we'll be happy to kind of take any kind of long discussions with you outside of this webinar. But also, I think that the real way to understand the potential of this is obviously applying it to something a little more relevant. So any existing projects that you have that we can come to site, do some scans, walk you through these workflows in a little bit more detail, I think that'd be hugely beneficial. So please get in contact, and we're more than happy to help.
All right. Thank you very much, everyone. And we'll speak to you next time. Bye.